In this video, we're going to go through the simple steps of how to draw Lewis diagrams. And we'll go through a couple of examples, and we'll start with this one, hydrogen cyanide. Now the first step is to draw the simple skeleton. And in this case, it's just HCN, like this. However, there are some rules on exactly how you write them. If you've only got 2 electrons, then it doesn't matter which way round they are. But if you've got 3, then one of them has to be in the middle. So the one that goes in the middle is the least electronegative. If you look at the periodic table, you'll notice fluorine. That's the most electronegative atom. So in your molecule, the one that is furthest away from fluorine goes in the middle. In this case, we're dealing with hydrogen, carbon, and nitrogen. See, hydrogen, there's a rule about hydrogen that it's always on the outside. But of the other two, carbon is the least electronegative, so that one goes in the middle. The next step is to count the number of valence electrons that each of these atoms has. And you count those on the data sheet in the periodic table. So hydrogen is in the first group, so has 1. We skip the transition elements and go to carbon, which is in the 4th group, so has 4. And nitrogen is in the 5th group, so has 5. If we add up these electrons, we see we have 10 electrons in total. So we have 10 electrons to work with to satisfy the bonding requirements of this molecule. Step 3 is to add a pair of bonding electrons between each of the atoms. So we'll add a pair of electrons between hydrogen and carbon, and another pair between carbon and nitrogen. Step 4 is adding the rest of the electrons, making sure that each atom obeys the octet rule. Apart from, of course, hydrogen, which only needs 2 electrons, which, as you can see, it already has. So what we do now is we see carbon has 4 electrons and nitrogen has 2. So we'll add the remaining 6 electrons around the nitrogen atom so that now it has 8. Step 5 is to make sure that all the atoms obey the octet rule. And as I said, hydrogen only needs 2, so it doesn't have to stick to the octet rule, but carbon and nitrogen do. As you can see, carbon only has 4 right now, while nitrogen has 8. So what we have to do is move some of the ones that nitrogen has to share them with the carbon, so that carbon can have 8 and nitrogen can have 8. So we'll move them like this, and now you can see hydrogen has 2, carbon has 8, and nitrogen has 8. And the final step is to replace bonding pairs of electrons with simple lines. So between hydrogen and carbon, replace the 2 dots with a line, and between carbon and nitrogen, you can see there's 3 pairs of dots, so we add in 3 lines. And there we are, the Lewis structure is finished. Now let's do another one with fluoromethane, CH3F. So to start with, we'll go to the periodic table and we'll see which group things we're in to see how many valence electrons we're talking about. Now carbon is in group 4, so we have 4 valence electrons. Hydrogen is in group 1, so that's 1 valence electron each, but we have 3 hydrogen atoms, so that's 3 in total. Fluorine is in group 7, so that has 7 electrons. So we come back, we add them all up, and that gives us 14 valence electrons in total. So now we'll quickly sketch our diagram. So we're still looking at the periodic table, and we notice that carbon is the one that's furthest away from fluorine. And remember, we discount hydrogen. That one doesn't take part in this. So carbon is going to be the one in the middle. So our diagram will look like this. Carbon at the middle, and then 3 hydrogens and fluorine around it. So now we add in our bonds. So we put a pair of electrons between each of the atoms, like this. And that's used 8 of our 14 electrons. So now we just have 6 left. So now the next question is, where do we put those? If we look at the hydrogen atoms, they have 2 electrons each, and that's all they need. But the carbon and the fluorine need 8. So the carbon, looking at that, it has 8 already. And the fluorine only has 2, so if I put the other 6 around the fluorine like this, then it's good. And everybody has the right number of electrons. And then the very last step is just to swap the bonds from pairs of electrons into single lines, like this. then here we have the completed Lewis diagram for fluoromethane.